Okay. Thank you for the kind introduction. I have to say that it's a great honor to be here. This is my first time actually at a live conference, so I hope we'll be seeing each other in the coming years. My institution is actually mostly known for doing soil and water samples, so in a sense this is some sort of pioneering research work. The title of the I hope soon to be paper is Health Risk Assessment of Particulate Matter Emissions from Natural Gas and Fuel Oil Heating Plants using Dispersion Modeling. And while the first two words are actually health risk and assessment, I would like to turn your attention to the actual comparison between the natural gas and fuel oil heating plants. Because as you see, in Serbia there are around 50 heating plants currently in operation, and they are currently going through some process of transition. Some of them are fueled by fuel oil, and some of them are by natural gas. Some of them are also fueled by coal, but the Valjevo heating plant was very interesting because it has actually two boilers. So one is fueled by natural gas and the other one is fueled by fuel oil, and that actually provided a really nice opportunity to do a comparative study, a comparative analysis between these two fuelants. So regarding heating plants, we all know that they are mostly powered by fossil fuels. Heating plants and district heating systems are present all over Europe, and yeah, they are big contributors to the air pollution of the surrounding areas. In Serbia especially, the heating plants are actually focused, are very near in the vicinity of the cities they are providing heating energy for, and yeah, they have general big contributions to the PM concentrations, to the SO2 NOx concentration, etc. As we can see here, we have a picture of the study area, and what is immediately apparent if you look at the picture is the closeness, the vicinity of the heating plant to the actual city center. It's maybe even less than a few kilometers away from the actual city center, and that's why Valjevo really proved to be a really nice place to perform our study on. The other thing that's interesting is that we actually performed live measurements of the pollutants. So we used international ISO standards for the determination of the various pollutants and parameters. So we were measuring CO, NOx, SO2, particulate matter concentrations, oxygen, and of course the velocity and the flow rate of the exhaust gases. And by knowing the concentration, by knowing the flow rates, and by knowing the diameter, we were able to, using of course state-of-the-art equipment, we were able to not estimate, but actually calculate the emission rates of these few pollutants. The next part of the study was actually using these emission parameters to estimate the actual pollution and that is put onto the city of Valjevo, and for those purposes we used the RMOD air dispersion model. So RMOD is a steady state dispersion model that is used for short range dispersion, so less than 50 kilometers in range. One thing that's not very well known is that most of the countries in Europe actually have their own air dispersion models, and RMOD is very interesting because it is the recommended air dispersion model by the EPA, and that's why it was our air dispersion model of choice. It is, if I'm not mistaken, used by the United States and as well as Canada, and yeah, that was our model of choice. So In essence, we combined the live data that we acquired on site by measuring the emission rates at the stacks, together with the modeling power, so to say, of the RMOD model. And in order to properly assess that, we had to provide some key input information. So first off, I did mention that we acquired the emission rates, which was very important. Apart from that, we also had to find the geometry. So we used the SRTM maps with a resolution of about 90 meters, and we also used the weather data from the past 5 years, which we thought was enough. So I know this isn't a meteorology conference, but here you can see the windrows of the city of Valjevo. So we can see that we have a strong winds coming from the west, which does seem to fit nicely with the topology of the city, which you can see at the picture here. And now I'm going to briefly go over the actual results of the modeling. So here we can actually see the actual impact of the heating plant onto the city itself. So these are the concentrations of the PM particles, and this graph is tied to the fuel oil boiler. So we can see a 3D map here, and we can see the concentrations of the PM particles given in micrograms per meter cubed. And yeah, this graph really nicely shows how big the impact of the heating plant is. You can see this area here is actually the city center. So the good thing actually is that the wind is blowing to the east, so the brunt of the pollution is actually carried away from the city, but still we can see a significant concentration of PM particles within the city. Now this is why I said that I would like to focus on the relation between the fuel oil and natural gas heating plants. Now I'll show you the PM particle distribution of the natural gas stacks and boilers. So this is it. I pretty much used the same scale to just show you how less of PM particles emissions are emitted by the boilers that are using natural gas. So there should be a small red spot around the heating plant, but I guess that it's not too visible. So yes, I will now go over the other pollutants that were also measured. So this is the CO, ground level distribution. Again, we can see a similar pattern to the PM particles, and the natural gas boilers do have a much less pronounced footprint on the city. Okay, this is the SO2 distribution. We also know that SO2 is a significant contributor to the hazard index, and this is of course for the fuel oil. And if we go to the natural gas boiler, again the pollution is at least between 10 and 100 times smaller for the natural gas emissions. And lastly, I believe this is the NOx distribution. It follows a similar pattern, and this is the distribution for the natural gas. I do have to note that the boilers, even though they are very close and they have very similar physical properties, the main difference between them is that the fuel oil boiler operates at a power of 50 megawatts, and the natural gas boiler operates at a 30 megawatt power. So we can understand that the NOx emission, the pollutant emissions from the natural gas boiler should be, of course, lower, but still, if we look at the graphs of the PM distribution, of the SO2 distribution, we can, without any doubt, assess that the natural gas boilers have a significantly smaller footprint on the environment and on the health of the citizens of the city, and basically used four different sampling spots in the city, and we used as much of the health risk contributors we could find. I again state this is not the total health risk, because this does not factor in some, for example, heavy metals like arsenic, which are also always present when we are talking about fossil fuel emissions. And these blue bars, I believe we can all assume what they do, what they represent. The blue bars represent the health risk that was estimated by that was coming from the fuel oil boiler and stack, and the green bars actually represent the health risk that was calculated from the natural gas boiler and stacks. So one definitive conclusion that we can draw at the end of this presentation is that the transition to natural gas is favored and good. Of course, it's still a far cry from living in a green future where we don't have to rely on fossil fuels at all. But it's a great step forward that is being undertaken at some district heating systems in Serbia. So I'd like to thank you for your attention.
So, thank you, Dr. Cirovic. Are there any questions?
I have a question.
Please, Rock Novak.
I think you can hear me. Do you know, are there any cleaning or NO2 reduction facilities present in these boilers for natural gas?
No.
No.
They should be present in these specs, but we're informed by the competition that they are aware.
Oh, okay. What about fuel oil? Any cleaning device for SO2?
I think
No.
no.
Okay.
Should, but
Okay.
Any other question? If not, thank you, Dr. Cirovic. And so, compliments for your first presentation in his career. Okay, perfect.